Golang is the language in which most of the cloud-native projects are written, and the flagship project of cloud-native is Kubernetes. By combining these two, we can build Kubernetes Operator, which is a way to extend Kubernetes capabilities by automation that doesn't exist out of the box and tailored specifically for your app. And in this video, I'll guide you how to build your own custom Kubernetes operator that fits your needs. The agenda for today is the following. Firstly, we'll go over high-level architecture of Kubernetes and understand where Kubernetes operator sits. Secondly, we'll learn core concepts of Kubernetes operator. And finally, we'll build a real Kubernetes operator which manages number of pods depending on the time of the day. Really excited about this one. Cool topic. And let's get some coffee and dive right in. First things first, let's talk about Kubernetes architecture. Let's start from the client side. For Kubernetes client, it's either curl HTTP client or kubectl, you executing the commands in the terminal. So when you execute command, let's say you want to create some deployment, your request comes to the control plane node. It's the node where all of the Kubernetes objects are located. We'll go over them in a second. And also we have a worker node. It's where your pods and applications are running. Nice. First entry point to Kubernetes is kubeAPI. You essentially communicate with this component. What it does, it performs REST operations. So authorization, authentication, admissions, and also all of the commands that are executed, it's essentially just stores to etcd. It doesn't have any complicated logic inside. It just performs CRUD command, create, read, update, delete, with Kubernetes objects like pods, jobs, CRDs, and etc. And etcd, it's NoSQL database where all of the Kubernetes objects are stored. Actually, all of the logic in Kubernetes perform kubectl manager and its controllers. The kubectl manager runs controllers, and we have various of them. For example, node controller, which reads node health, update node status, maintains, delete pods via eviction. We have deployment controller, which manages rolling updates, rollbacks, replication controller. It ensures correct number of pods. And what all of these controllers, and we have many of others, have in common is that they perform the same loop. So no request coming directly to the controller. All of them working in the listen node. They constantly pulling information from the kubeAPI. So they are listening for events, and when some event comes in, they do reconciliation. Reconciliation is the movement from actual state to the desired state, and perform some logic. For example, replication controller, it receives action that number of replicas has decreased, and it moving from actual state, current number of replicas, to desired state, the number of replicas that were set in the deployment. And this logic is called reconciliation. And then it performs some action. It does request by itself to kubeAPI. So it says add more replicas. And that's what's happening, how it works end to end. And then we have a worker node with kubelet. Kubelet actually watches also all of those events and perform actions. So for example, if replica set controller wants us create more pods, kubelet will listen those events and create more pods. And kubeproxy makes our service available in the internet. So essentially when you create service layer, load balancer, or any other type, this component gets involved. Nice. And one last component which we haven't captured is kubescheduler. It decides to which node we need to assign new pod or deployment on any other objects. And here comes Kubernetes Operator. So first thing that we need to do is to ask Kube API to create new custom resource definition and custom resource. We'll discuss what it is in a second. Then we'll go to and create our custom controller. This logic will be written in Go. And essentially, same as all of the other controllers, it will perform reconciliation, moving from listening for events and moving from actual state to the desired state. And then write actions to Kube API. And it can perform pretty much any logic so that will be needed for your application. Therefore, Kubernetes operators are really powerful and nice and cool to use. Switching gears and talking about core concepts of Kubernetes Operator. First one is custom resource definition. It's the schema that defines a new Kubernetes API objects that extends Kubernetes API with a new kind, similar to pods, services, and so on, but which doesn't exist out of the box. And custom resource is the new Kubernetes object that gets created according to the scheme. So let's say we have time window scaler CRD. Essentially, which should help us to increase the number of pods during specific time. If it's out of this time window, we decrease the number of pods. That's essentially the logic. And we create a new instance of it with the time window scaler working hours that specifically for some application that focusing on employees. And during working hours, we need more replicas to handle the load from 9 to 5. It must be 5. But out of this time, it's fine to have only one replica. And our Kubernetes operator, which written in Go, will be constantly listening events associated with this custom resource and move number of pods from actual state. Let's say we have during working hours only 2 pods to desired state to 5 pods. That's pretty much end-to-end logic of Kubernetes operator, and I hope it helped you to understand the concept. Alrighty, it's finally time to create our own Kubernetes operator. We finished with learning all of these concepts. Let's get our hands dirty. So here the GitHub repository with Kubebuilder, which we're going to be using. It's a framework for building Kubernetes operators. And it actually helps to speed it up the process there. Other ways with operator SDK and so on, but I find it way longer. So if you follow the instructions, we'll get started, you'll be redirected to their website, and then you need to install this Kubebuilder. Also, you need to set up your Kubernetes cluster. I assume you already done it. If not, please find it somewhere in the internet. There are a bunch of tutorials on that topic. I personally prefer multipass with kubeadm for local development. And if you want, I can create the tutorial on setting up Kubernetes operator in a separate video, but it definitely goes out of the scope of this tutorial. First thing that we need to do is to initialize our project. For that, we'll execute the following command, kubebuilder init, and we'll specify the desired name for the repo where the project will be stored. So it's my GitHub. Then the main example.com because we don't care, and project name. So we specified all those things. Let's execute. It gets initialized. Nice, just inside. Perfect. That's what we wanted. And the next step will be to create and API. So we are saying that group is auto-scaling, version the following, and the kind that we want is time window scaler. So it can be any name here as you wish. So as far as we're creating the Kubernetes operator, which will change the number of pods depending on the time window, I decided to name it in this way. Okay. We agree with everything, and our repo gets created. So downloading some additional stuff. Let's wait for a bit since it's loading. Okay, now it's ready. Cool. And here we need to change a few things. Here are a lot of folders. For example, here we start the project, the server. Here we have the binaries built. Here an API, we have types defined. An internal, we have actual controller with the reconcile logic that we need to create. Firstly, we need to define the types. And here the struct that has been created for us is some default field just to show us what are the capabilities and what we'll create. As I showed previously on the example, we want to have time window object first. So I will add it. Then we need to basically add this object right here. Then we need the number of replicas. Let's create this type. It is created. And now we need to find this as the field of this struct. Essentially, those are the fields inside of the spec and YAML file. And we need also a target ref, which will show us the objects which we want to monitor. So in our case, it will be only deployment. And here's the name of the deployment, must be specified. That's it. The time window, start and finish, number of replicas during this time window desired and out of the time window, the name of the object, in our case, the name of the deployment, and the kind of deployment that we will specify. Those are the fields that are required for our Kubernetes operator. Now, since fields are defined, let's implement actual reconciliation logic. For that, we go to internal controller and time window scaler controller. There are also other files, but they're for the tests. In scope of this tutorial, we don't need tests, but for production, don't forget to add them. Better to be safe than sorry. Cool. So firstly, we need that log. Secondly, we need to get our CR object. Adding the imports. Okay, and what is happening here? Firstly, we created an instance of our objects, our time window scaler that we defined right here with the spec and all of those fields. So we want to get those fields to know how many replicas our user wants and what is the target reference and what is the time window specified, right? So for that, we're making call to kubeAPI server, and we are providing the namespace and the object which should get this data essentially. If we've got an error, we'll return it. If it's not found, if we don't have any custom resources created, then we just skip it. Cool. The next step is to do validation. What has been specified as the kind? Was it deployment? If it's not deployment, we would like to return an error. Cool. And then we want to do the logic to increase or decrease number of replicas depending on the time of the day. So I will create this variable which will contain the desired number of replicas, and I will add here one more condition. So this is the function that we need to implement within time window, to which we'll provide the start time and end time that's specified in the custom resource. And depending on the time that happens right now, we'll find out what should be the desired number of replicas. If it's within time window, we specify a value that was in the custom resource in time window. If it's out of time window, accordingly specifying the value. Okay, let's actually implement this within time window. For us, it's not really important because it's simple Go code, not related to Kubernetes Operator. And it doesn't cover all of the edge cases, hasn't been tested, but it's sufficient for educational purposes, right? So here we parse string to hours minutes format. And we need to specify the time zone, and I wanted it to be always Europe Central Time Zone. I'll define it here on the top. And this one will be requeue interval. So for example, if we realize that the state is desired, in which period of time, in which interval we want to check it again. This will be responsibility of this interval. Cool. So here we know now the desired number of replicas. And now we need actually to check what is the current state of the deployment. For that, we'll be creating object for the deployment. For that, we need to add some imports because these objects are already defined. Kubernetes library. So we've got the deployment, we've got the namespace of our scaler and target reference name. And every 30 seconds, we'll be asking to provide us in the following namespace, the following deployment. For visibility, we'll add some logs to know what deployment we received, how many replicas it has, and what is the desired number of replicas that we'll find out by this function. Oh, something happened with this. Cool. We are checking the number of replicas desired or not. If desired, we again check in 30 seconds, as I mentioned in the past. And if not, we ask KubeAPI server to change the number of replicas according to the desired number right here. Once it's done, we show the desired number of replicas has been applied, and then we check again in 30 seconds interval. And that's it. We've finally written reconciliation logic. The next thing that we need to do is to add more role-based access control permissions, because by default, we cannot operate with deployments, but we want to have that capability. Therefore, I need to add that line to my reconciliation function in the comments. So when I execute command make manifest, which provided right here, my file with the role-based access control will be updated. So I'll go here, role. As you can see here, we don't have much roles defined, but if I execute make manifest right now, we see that all the roles have been defined, and especially the one that I added for deployment. So we can perform those operations, especially patch, we are interested. But the good practice is to keep as less operations as possible, as less verbs as possible for resource that you select, and to have as less resources as possible as well. Okay, so let's have a look on the sample section. So we have in the CRD based our custom resource definition defined. So it has kind, in plural, it will look like this. So we can execute kubectl time window scalars, and it will show the list of time window scalars available. And here in the sample section, we need to define the actual custom resource, the instance of this custom resource definition that's located right here. For that, I will specify all of the required fields, which are the following. We have time window, start, and here are some values. Replicas, during the time window, we want to have only 5 replicas. Out of the time window, only 1. Kind deployment, because only this object we support. And here the name of the deployment, which we will be listening. And that's about it. And now we need to create the deployment that we'll be using for testing with the name temp test. So I'll create new file, and it will look as follows. So it's simple deployment, which has only 1 replica by default, and it runs simple open source image with Nginx. And the most important part that it has name temp test, and that's what we need. To run it in our Kubernetes cluster, firstly, we need to execute generate and make manifests. But we already done it, but just to be safe, I will show it again. So we're executing those commands. Once it's done, we need to execute make build to build a binary, then Docker build and Docker push to build an image and push it to Docker Hub. But later it will be received by our Kubernetes cluster. And for Docker Hub, I prefer using TTL SH. It's the free Kubernetes registry, and I use it for my pet projects or some tests, but definitely not for production, because it's not safe to store there. Everybody can access them, but if you don't care, it's okay. So it will be there for 1 hour and then disappear. And I added random name to it. I exported it as an image because it's inside of the make file, this variable. And when we'll be executing make commands, it will use this environment variable and will create images accordingly. Cool, I exported it, and now let's build and push an image. Okay, finally build has been finished, and now let's create a new custom resource definition. We can do it simply by executing make install. Our custom resource definition gets created. Once it's created, we can check if it is there by kubectl get CRDs. And we see it's there. Now let's apply our config with this time window. I'll slightly change it to 20. So from this time period to this, we should have 5 replicas, and out of this time window, only 1. Cool. So let's execute kubectl apply and create those samples. Samples have been created, and now we are ready to deploy our Kubernetes operator by make deploy command. So Initially, right now, okay, probably it's already late, but doesn't matter. So initially, we had in our deployment only one replica. Now, since we're in the time window, I should have 5 replicas. Okay, only one replica right now is working for some reason, and we're still in the time window. That's weird. Let's check what happens in the logs. It hasn't started yet. Okay. Okay, so we see that it increased the number of replicas. Yeah, number of replicas have been increased, and we still, now it's midnight 20, so we're still inside of the time window, and we set the desired number of replicas to 5. It's great. Let's wait a minute. When it will be 21, we should get out of the time window, and number of replicas should be increased automatically to 1. Okay, we see the desired number of replicas have been applied. Let's see. We see pods get terminated because we went out of the range of the time window. And eventually we've got only one pod running. So our Kubernetes operator works as expected. I hope you enjoyed. Congratulations, you made it till the end. I'm proud of you. I hope you enjoy the video, this tutorial about Kubernetes Operator. So we went through high-level architecture, we ran core concepts of Kubernetes Operator. We built actual Kubernetes Operator and deployed it to Kubernetes cluster and see it's running end-to-end. Isn't it awesome? I personally enjoyed it. And I wish you good luck with building your own Kubernetes operators and applying in your own projects. Let me know what kind of Kubernetes operator you want to build in comment section under this video. And I'll see you in the next one. Bye.